Okay, we're going to walk through a hypothetical, but, a very possible energy crisis set in 2026. But we're not just going to stop at the problem. Nope. We're going to decode its impact and, more importantly, look at the actual engineering solutions that could build us a much more resilient energy future. To really get a sense of what's at stake here, just let this number sink in. 30 million barrels. And that's not per week or per month. That's every single day. This isn't just some abstract statistic. It's literally the lifeblood of the global economy, and it's all flowing through one of the most fragile points on the entire planet.
So here's our game plan. First, we'll look at the world's energy artery. Then we'll talk about the price of a crisis. After that, we'll dive into how we can decode market fear. And finally, we'll wrap up by exploring how we can design much more resilient grids for the future.
All right, let's jump right in. Section 1, the world's energy artery. We're starting at the absolute heart of the global energy supply chain, a place where the world's economy is, frankly, incredibly vulnerable. I want you to think of the Strait of Hormuz not just as some shipping lane, but really as the world's main energy artery. It's incredibly narrow, and it connects these major oil producers in the Middle East to, well, pretty much everywhere else. Any blockage here doesn't just slow things down a little bit. It sends immediate, massive shockwaves through the entire global economy.
So, what happens when this artery gets squeezed? That leads us straight into Section 2, the price of crisis. And here, we are talking about the immediate and, honestly, severe economic fallout.
This is the multi-trillion-dollar question. It's the one that keeps economists, geopolitical analysts, and world leaders awake at night. The potential for disruption is just so huge that a massive amount of brainpower goes into modeling exactly what would happen. And this is where the numbers start to get really serious. The experts over at Fitch Ratings modeled what this price shock would look like, and the scenarios are, well, they're pretty stark. Just look at this chart. In a normal, base case scenario, we're looking at about $70 a barrel. But just a 3-month closure of the strait, that sends the average price skyrocketing to $100.
But wait, it gets worse. If that closure stretches out to 6 months, the average price for the entire year hits $120. And that word average is a little deceptive, because during the peak of the crisis, prices could spike to an absolutely eye-watering $170. That's not just a number on a chart. That's the cost of gas, the price of groceries. It's everything.
So price is a number, right? But what's driving that number is often something you can't really touch: fear. So how do experts actually measure the panic that fuels all that market chaos? Well, this is where we turn to the really cutting-edge world of artificial intelligence. The main tool here is something called sentiment analysis. The easiest way to think about it is like teaching a computer to read the room. It uses AI to scan millions of news articles, social media posts, you name it, and it's looking not just for keywords, but for the actual emotion behind the words. Is the collective mood optimistic, or is total panic starting to set in?
And one of the most advanced AIs for this job is called BERT. Now, don't worry about the complicated diagram. All you really need to know is that BERT is basically a super reader. See, older AI just read from left to right. BERT reads the whole sentence at once, so it understands context, nuance, even sarcasm. It's the difference between just seeing words on a page and actually understanding what they mean.
And the link here is direct. It's statistically significant. Research has shown that as the AI detects more negative or pessimistic feelings in the news coverage of a crisis, the stock market, like the S&P 500, it becomes way more unstable and unpredictable. It's like having a real-time gauge of market anxiety.
Okay, so we've seen the vulnerability. We've seen how to measure the fear it creates. So that brings us to the final, and I think the most important part: designing resilience. How do we build a future that's just stronger? Well, the answer lies in completely rethinking our energy infrastructure from the ground up.
A huge part of the solution is moving away from our old-school, centralized power grids. These legacy systems have single points of failure that make them incredibly vulnerable. The future is in microgrids, these decentralized local energy networks that can actually operate on their own, which makes them way, way more resilient. But a modern microgrid isn't just about preventing blackouts. As you can see here, the best design is really a finely tuned balancing act. It's engineered to optimize for 4 key things all at once: keeping costs down, emissions low, efficiency super high, and of course, making sure it's absolutely rock-solid reliable. And this right here is the secret to their resilience. Microgrids don't depend on one single faraway power plant. They use a whole mix of local energy sources: solar, wind, battery storage. And here's the key. If an oil tanker gets stuck in the Strait of Hormuz, a city powered by local microgrids is basically insulated from that shock. It creates a stable, self-sufficient power supply that just isn't dependent on these global choke points. And that leaves us with this final thought. The energy challenges we're facing in the 21st century, they demand more than just making our systems a little cheaper or a little greener. The real challenge, and honestly the real opportunity, is to make them fundamentally stronger, smarter, and more resilient. So the question is, are we ready to make that shift?